I am Krishna Rao Patro. Today we will discuss about one more important problem, that is bubble sort. One of the simplest sorting technique, that is bubble sort. The name indicates you are sorting the elements with bubbling. That means it will be checking always its neighbors, and if the neighbor is bigger, then just interchange. So always the smallest element comes first, next, and then next. So you have to compare you with your neighbor. If your value is greater than your neighbor, then interchange it. So keep on going like this till last. So the bigger element will be going to end. So in every iteration, the biggest element will go to at the end of the array or end of the list. So this will continue till end. This is the idea behind this bubble sort. First of all, you should know what is sorting. Arranging the element in ascending or descending order is called sorting. So bubble sort you can apply either for ascending order or descending order. Bubble sort is the simplest sorting algorithm. It works by repeatedly swapping the adjacent element if they are in the wrong order. Okay. The time complexity will be order of n square if it is normal bubble sort. If it is normal bubble sort, and the time complexity will be order of n also if it is updated bubble. That means you can change. So if you want to speed up, you can modified bubble sort you can use. In the modified bubble sort, that is order of n, and the average case, the time complexity is order of n square. The worst case, order of n square. This is for modified bubble sort. Modified bubble sort. This is for the regular bubble sort, order of n square. Similarly, the memory requirement is fixed, that is constant. There is no changing in the memory size, and it is also stable as well as it is in place. So this is very frequently used sorting technique. And for the smaller size of data, whenever the size of data is small, that time bubble sort is more useful. Whenever it is a huge collection of data, bubble sort is not suitable, not advised to do, because its time complexity is almost order of n square. And the algorithm behind this sorting, you can start the first element that starts with the 0 index, compare with the element with the next element of the array. If the current element is greater than the next element, then swap them, because always you have to swap with the neighbors. The biggest element will go to at the end. If the current element is less than the next element, then move to the next element. Repeat the step 1 until you swap, means until the entire array is sorted. Let us take the set of data 21, 54, 36, 18 and 29. These are set of data. This data I want to sort it out. Assume 21, 54, 36, 18 and 29. That means we are comparing 21 with 54, your neighbors. But 21 is smaller, no need to interchange. Then compare 54 with 36. Now 54 is bigger, so swap it. So automatically it has come here. Compare 54 with 18. Once you compare, 54 is bigger, so it goes here. Now compare 54 with 29. So 54 has gone. That means at the end of the iteration, you found the biggest element at the end. So please remember, every time you are comparing with the neighbors, if this value is bigger, then swap it. If this value is smaller, don't need to swap. Now you see here, no need to swap. Here 54 and 36, swapped here. 54 and 18, swap. Then 29 and 54 and 29, swap. So at the end of the iteration, 54 has reached to the end of the loop. So in the second iteration number 2, so this element has already reached end. So now the remaining element you have to focus. So this element you have to skip. 21, 36, compare the neighbor. 21 is not bigger, no need to interchange. Then 36 and 18, compare. If 36 is bigger with 18, then swap it. So 36 has come here. Then compare 36 with 29. Always you have to compare the neighbors only. Then 36 is bigger than 29. Then swap it. Then compare. Now you have reached at the end. That means your second iteration is over. Second iteration is over because 54 has already reached in the first iteration itself. Now the second iteration stopped here. Now go to third iteration. So in the third iteration, you have to focus on these three elements only. These two are already swapped. So that means the loop will not come this side. It will every time the outer loop means the inner loop is reducing. Inner loop is reducing. Then you are comparing 21 with 18. 21 is bigger, then it has to interchange. Then compare 21 with 29. So here 21 is smaller, no need to interchange. So that means 21 has reached at the end of the array. That means at the third iteration, 29 has reached to the respective place. Now go to fourth iteration. In the fourth iteration, these three are already over. Only you have to focus on these two. Okay. Now compare 18 with 21. 18 is smaller, no need to interchange. That means 21 has reached to its respective place. So when 21 has reached here, nothing to. So that means this iteration is stopped here. So finally, that means if there are n number of elements, the iteration will be n minus 1. And finally, the sorted list will be 18, 21, 29, 36 and 54. So this way you are getting the final using bubble sort. So one of the simplest sorting, and in most of the exam they'll ask, write the bubble sort algorithm. So the modified bubble sort will be a little bit different. If it is already no need to interchange, even the first swap, if there is no interchange at all, then you can stop there itself. So after first iteration, you can stop there itself. Now you can write a bubble sort program using Python. See, when you want to write bubble sort program using Python, what you have to pass? You can write a small function called bubble sort, and you can pass the array as a parameter. And first you find the length of the array. The length of the array says how many times you have to iterate. So if length is 5, you have to iterate 5 minus 1, 4 times. Outer loop will repeat 4 times. And the inner loop will repeat n minus I minus 1 time. That means if I is 1, means 1 iteration over, you should reach last but 1. That means every time n minus I steps, you have to go internally. So after first iteration, after end of the first iteration, the first biggest element will go to end. After the second iteration, second biggest element will go to the last but 1. So that means in every iteration, the last position will be filled with bigger elements. So this will continue till end. So this way it works. If you go for inner loop, for j in range 0 to n minus I minus 1 minus 1. Here, what happened? You are comparing every time from 0 to till n minus I minus 1. So outer loop goes also n minus 1, but here n minus I minus 1. Every time the I steps reducing. Already here outer loop is n minus 1, and this loop is, you can say, n minus 1 followed by I steps reducing. And here we have to do, this is my j, and you have to compare j with j plus 1 neighbor, because j and j plus 1 are neighbors. So we are comparing j with j plus 1. If jth element is bigger, if this element is bigger, then interchange. Otherwise don't interchange at all. That means swap it. If this condition satisfies, you interchange. Because your goal is the biggest element should go to end. That's why you swap it. So this will continue till end. And put a master method. Initially this array is there. This is the given data, and we are calling the bubble sort program and printing the things. So this way, let us write the bubble sort using idle. Now let us go to idle. Now I'll open a new window. Alright, bubble sort. Now we'll write a method called bubble sort method, bubble, and here I will pass the array. That means my list is there. Here what I will do, I'll put a loop for I in range, for I in range bracket length of ARR. So it starts from 0 to up to length, but I will not go to up to length. I have to reduce length of array -1, and my inner loop for j in range of 0 to, every time it will start from 0 to, here what I will do, I will instead of that I will take an array value n equal to, I will store here, instead of writing this time every time, I will write n equal to length of array -1, Control C, Control X, n. So this value I will write like this, okay, and 0 to n minus I step. Every time in ith iteration it will reducing. Now here what I will do, I will compare my neighbor elements. If array of j, if this value is greater than array of j plus 1, if this condition true, here I will swap. How to swap? Array of j, comma, array of j plus 1 equal to array of j plus 1, comma, array of j. So now it is swapping. So this is swapping for all the elements. When my loop is over at one iteration, internal iteration, that means the biggest element will be reached at the end. When the outer loop is over, all elements are swapped. Means it has reached to the respective position. Now here I will write my array equal to, I will read the data, read int of the element x for x in, I will write here input dot split, input dot split. So here what happens, whatever the data you are reading into string and then splitting, and every element of the list converted into integer. That means you are getting a integer array. Now you will call bubble sort. I will call now bubble sort within bracket ARR. Okay. Now print it, print ARR. Now here I will write after sorting, print after sorting Control S, bubble sort F5. Yeah, there is a small built-in function method object, no attribute split. Input is a method. So here you should write input function. Input is a function, so you should write this. Control S, F5. I am entering the data 11, 2, 3, 4, 5, 6, 7, 7, 8. Yeah, 2, 4, 6, 8, 11, 33, 55 and 77. This is the sorted data. So here also initially it was showing nothing. So better in the input method you write a message, enter data, enter data. When the message comes you will enter data. It is better to give always a message for entering the data. assume 4, 55, 6, 77, 8, 9, 9, 21. Yeah, 4, 6, 8, 21, 55, 77, 99. All the elements are sorted. So this way you're able to do this. This one is a simple sorting. This is a normal setting. And you can updated sorting. That means you can enhance modified sorting also there. Bubble sort. This is regular. And normal sorting also available. This is the regular sorting. But you can minimize the time. You can minimize the time. See now. Till now you have seen the regular sorting. It is normal. Whereas there is optimized sorting or you can say modified sorting. This optimized sorting also called modified bubble sort. Modified bubble sort. So in the modified bubble sort, please observe here. This is also equivalent to same sorting, but in every iteration, whether the elements are swapped or not. If at all elements are swapped, then okay. If elements are not at all swapped in the first iteration itself, so no need to do remaining iterations. So that means here you have introduced a variable called swapped. Initially swapped is false. So if at all the elements are swapped, that means if array of j is greater than array of j plus 1, then I am writing swapped equal to true. Otherwise swapped is false. If swapped is false, it means what? There is no bigger element as 1. That means already everything is in a sorted order. If it is false, simply break the loop. Nothing to repeat the iteration. So it has repeated how many time? N time. That means in the best case. So this case will arise whenever the elements are already in a sorted order. So if the data is already in the sorted order, then the time complexity will be order of n. This is only in the rare cases, or you can say best case. For the sorted order data, if you apply this optimized version, this is called optimized bubble sort. Okay. So there, this will repeat only one time in internal iteration. Remaining time is false, come out from the loop, then it prints. So optimized bubble sort is faster than the normal sort. Now you see how we can change the program there in the idle. Now see, same program I will write in a optimized bubble sort or modified bubble sort. Sometime in exam they will say optimize bubble sort, or you will say modified bubble sort, or modified. Both are true. Modified, optimized or modified bubble sort. So here what I will do, same program, but you have to introduce a variable called whether modified or not. We will make a flag. Initially flag is false. Means I will say swap flag. I will make variable called swap flag. So initially I will say that nothing is changed. False means in the Python the f should be uppercase. Now here whether it is swapped or not, how will I know? So here if the if condition true, it indicates there has been changing, means swapping. So here I will write here swapped flag equal to true. So it indicates that yes, there has been some swapping occurs. Now when the loop is over, first iteration is over, that time my swap variable I will check whether it is true or false. If swap flag, swap, here the variable name is swap, SWAPP. So same name you will write. If swap flag equal to false, that means there is no swapping at all, then no need to continue the loop. So simply break the loop. So this is my optimized bubble sort. Now remaining programs are same. This part is same. This is reading, and then you are calling the bubble sort with the array as a parameter, and after sorting you are printing. Now you see F5, 11, 2, 3, 4, 55, 6, 77, 8. This is the given data. Yeah. Now I got that. And this optimized sorting is faster than non-optimized. or the regular setting. And this program also you can write in a object oriented way also. Now let us write same program in a optimized program in a object oriented approach. This is non-optimized, means non-object oriented. So how to write in a object oriented way? Same program. Please observe here. Whenever they ask, write the program in object oriented way. So here what you have to do? Introduce a class. I will write bubble sort, the name of the class, and put a colon symbol. And here I will not write my init method also. I will pass, or you can, even if you want to write init also, you can write def underscore underscore init underscore underscore, and you have to introduce a keyword called self. Okay, and here I will write my array as a member variable. Self dot array is empty list. Initially it is a empty list, and you want to make this as also a member of this class. So right here self keyword, and this ARR is a member variable that you can access directly by writing self. So here I should write here self dot ARR. So I have introduced this, and my for loop swapped here, and here I am not using this array name, and here I will write here self dot ARR. So that means I am using my member variable, and here also I will write here self dot ARR. Whenever you are accessing any member variable, then you have to use this self keyword in Python. And here also swapping occurs when the internal loop is over. So self dot ARR, and here also write self dot ARR, because you are modifying the structured program to object oriented program. Self dot this, self dot this. Now here when my internal loop is over, there you are checking whether swap flag is false or not. If it is false, the complete loop is terminated. It says that already elements are in a sorted order. This condition will true only in the special cases, but not for all cases. And once this work is over, bubble set is ready. Now you have to write a program for reading the data. So def space read data, and you make this as a member variable, and here you have to read it. So self dot ARR. So my reading is over. Same data I am taking there, and print data. So def print data, and this also your memory variable. So here this printing I will call here Control X. Here I am calling, just printing a message, then print this. Then this program I should call now. I have to create object first. What is the name of the class? The name of the class is object, means bubble set. I will write here obj equal to bubble underscore sort. So when you write this one, automatically the constructor will be called and object will be initialized. Once the object is initialized, then you can do the operations. So initially the empty list is created, then you can call obj dot read data. So reading data is over. Once the reading is over, then you can call obj dot bubble sort bubble underscore sort. And remember, these names you make better do not write underscore, write sort, because for clarity purpose. So here also when object is created, that time also I will remove this underscore, the name of the class. Okay, and while calling I will call this way bubble set. My obj is ready. Then I will call obj dot print data. So reading, sorting, and printing. So F5, yeah, now I'm reading data 11, 2, 33, 4, 55, 6, 7, 7, 8. This is the given data. but name error is not defined. So here you write self dot error. So because in object-oriented programming, do not write directly error. So you should write here self dot error because it's a member variable. First initially I found the length. After that I in range of n, swap flag equals for j in range 0 to n minus I, self dot error if it is greater than self dot error of j plus 1. If this condition true, we are making swap flag is true, and when the entire internal loop is over, it comes out, then you are swapping j with j plus 1 are swapping, and you are this you have to swap, and yeah, so this must be inside the if condition, and this condition, this is out of loop. Yes, f 11 2 33 4 55 6 7 7 8. Yeah, 2 4 6 8 11 33 55 7. So you must be very careful in the Python. If the indentation is not followed properly, you may get a wrong answer. So better follow proper indentation. So now you have implemented same bubble sort in 3 ways: regular way, optimized way, as well as object-oriented way. So anything you can convert the normal program into object-oriented program. So in object programming, please remember you should give the first class name, and then you write the constructor. This is your constructor. This constructor will be called whenever object is created, and these are all member methods. And while writing member method, you have to write a special keyword called self. So by writing self keyword, it makes this a member method. Otherwise, it is not a member method. It is a member method. Member method. Similarly, now this ARR also member variable. These are member variable. Member variable. And this read data also my member variable. That's why I wrote self. Similarly, print data also member method. So I wrote self. And inside that you can write your logic. And remember here n is not a member, it is a local variable. I is my also local variable. J also local variable. If it is a member variable, then I should write here self dot n. So in the init, you should write those things. But here I didn't mention. So my n is my local variable. So this way it works. Okay. So see the final 6 7 7 8 9 9 1 33. Assume this is a given data. Yeah. So there is a 1 6 8 33 77 and 99. So this is a sorted order of the data. Fine. So this way you can do. So practice well, and you can solve any kind of problem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.